Quadratic. What's a quadratic? 4. Yeah, that is a prefix for a 4. When they call this, I'm going to hurt myself, a quadriceps, does that mean it has 4 sections of muscle somewhere? Good. I like it. I don't know, honestly. That's not what it means here. Okay? Have you done these before? You've been doing them all semester. That's a quadratic. If I graph that, it makes a shape like that. If I invert it, that's exactly the shape this eraser makes if I throw it. Okay, you ready? Does that look like a parabola? Yeah. What makes it make that shape? Gravity. Okay? Anything you throw makes a parabola. So, functions, equations, guys, zeros, roots, x-intercepts, let's connect them. Okay, so quickly let's kind of skim over this kind of stuff. What's a function? If you recall from Math 10, if this is my graph, is that graph a function or not? I think it is, because it passes the vertical line test. Does every independent variable only have one dependent variable? For every input, is there only one output? Yes, there is. If it passes the vertical line test, it does. Whereas this thing, definitely not. For this input, I have 2 outputs. That's not a function. Okay? So, this is function notation, f of x. Okay? This is an equation of a graph. It's y. What's the difference? That's 4x minus 8. That's 4x minus 8. Shoni, not much. Okay? You can think of y just like f of x. It's just a matter of what we call it. That's a function. That's an equation. Okay? Don't worry about this imaging. I know that was in grade 10. I won't be doing it. Okay? This is function notation. What if x is 2? Can you find what the output is if that's your input? If I input it here, then I get 8 minus 8. My output, what's f of 2? Is 0. Okay? Same thing. X is 2. If I input it here, right, if you know what x is, you can find out what y is. That's my coordinate for x. 1, 2. What's y? 0. There it is. Okay? So we can say the 0 of a function is 2. Okay? The root of the equation of this is 2. What is a 0? Okay, well, we could have done this first, I guess. The 0 of a function is a value of the independent variable. Which one's that, x or y? X, which makes the value of the function equal to 0. So in other words, take the function f of x, let it be 0. Okay, here's a function. Let's let it be 0 and find that independent variable. Let's find x where this thing works. That's all it says. Okay, that's a 0. Notice there's a 0 here. Where is this function 0? That's what a 0 is. Okay, so just solve this. Find the 0 of this function, where f of x is 7x minus 21. Put it equal to 0. What is x here for this to be 0? Well, in grade 8, you would have went like this, right? Okay, so 7x is 21. Hey, what's x? I don't know. Let's get rid of 7. Okay, x is 3. Okay, that's the value of x that makes the function equal to 0. Okay, so the 0 of the function is 3. If this was an equation, oh look, that's an equation. Okay, the root of this equation is 3. Is there another way to do this? Yeah, we kind of did this too, didn't we? Could I factor out a 7 here? When is that 0? When x is 3. Same thing. You want to do them like that? Feel free. Okay? So, that's a 0. Investigation. That's a line. It's a linear relationship. There's the equation of that thing, and if you're really good at remembering your Math 10, maybe you'd even be able to figure that out. Okay? Y equals mx plus b. Remember, well, that's b. That's my y-intercept, minus 6. Yep. And then I would go 2 units of rise, 1 unit of run. Okay? And I would draw my line. Determine the x-intercept. What is an x-intercept? That's where it crosses the x-axis. There's one right there. Graphically, if you got the picture of it, you just write it down. What's the x-intercept? Where does this graph cross the x-axis? At 1, 2, 3, right? What happens at the x-intercept again? What's the value of y? 0. Have we seen that term already? Okay. Graphically, I know at the x-intercept, y is 0. So if I substitute y is 0, okay, at y-intercept, y is 0. Substitute it in. So 0 is 2x minus 6. Add 6 to both sides, right? So 6 is 2x, divide by 2. And what's x? Oh, that's shocking. Look at that. Okay? So if you got the graph, you look. There's the x-intercept. If you don't, algebraically, we can figure it out. Where does this thing have an x-intercept? Where does it cross the x-axis? When y is 0. Always, always, always. I don't care where the line is, right? That's where y is 0. Okay, determine the root of this equation. What do they mean by root? We kind of looked at it here. The root of this equation is 2. Why? Because if we put 2 in there, I get 0. Yeah. Well, so let's solve this equation. Have we ever seen this one before? Let's add 6 to both sides, and 2x is 6, divide by 2, x is 3. Oh, look at that. My root is 3. State the connection between the x-intercept of this graph and the root of that equation. Are they kind of like similar? Meryl, what do you think? They're the same. That's a pretty good connection, isn't it? Okay? So the x-intercept and the root are the same. Carmen, get outside, please. All right. Now let's look at a function. Have we ever seen this before? How do I find the 0 of this function? Hey, you got a good memory. The 0 of a function is where this function is equal to 0. Okay? So let's make that equal to 0. And, gee, I'm having a deja vu here. Okay? 6 is 2x, divide by 2. I don't want to cancel x, I want to cancel that. X is 3. That's the 0. Have we seen this before, Shelby? Your jaw dropped. You're like, wow, it's 3. Okay, Shelby, let's go way out on a limb here. What's the connection between the x-intercept? Where's that? Here. And the root. Where's that? And that's here. And the 0. That's here. They're all the same. Wow. Okay. Connecting zeros, roots, and x-intercepts. That's a pretty good connection, wouldn't you say? Okay. Let's go French. Jacques is determining da roots of da equation. X squared minus x minus 6 equals 0. They do that, don't they? Yes, they do. He wrote the equation in factored form. Okay, I hope we didn't forget factoring. Do you think you can all factor that thing? Luckily for you, we did that chapter first. That's a good coincidence, eh? Zero product law. Have you ever heard of something so strange? Determine the roots of the equation. I got x squared minus x minus 6 is 0. How do I find out what values of x make this 0? What times what is x squared? X times x. What two numbers multiply to negative 6 and add to minus 1? All right, everyone agree? When is this thing 0? Two? Yeah, that'll give me 4. That's not going to make a 0. If x is minus 2, I got negative 2 plus 2. This is 0. I don't care what this is. 0 times anything is 0. This thing works. If x is 3, I got 3 minus 3, 0. This thing also works. It's 0. Okay? So, complete his work. There's the roots of the equation. Shoni? Here's the actual graph. Who has graphing calculators? We'll be doing this tomorrow. If you got one, bring it, and if not, you might want to get one. If you plug that in, don't do it now. That's the picture it'll make. There's the graph. What are the x-intercepts? Like I said, if you got a picture of it, have a look. What does that point look like? It looks like about minus 2. What does this one look like? Kind of looks like 3. Have we seen this before? Hey, look at that. The roots, the x-intercepts, they're kind of similar. State the connection, Reese, between the x-intercepts and the roots. That reminds me of something. Have I ever told you guys the x-intercepts are the same as the roots?
I think you didn't agree.
Okay. Explain the connection between the factors. Okay, what are the factors of this? What are the factors of 6? 1, 2, 3 goes into 6, so does 6. These are all factors of 6. Factoring this. Have we done this already? There is a factor, x plus 2, of this equation. This is also a factor of this equation. Okay? Just like 2 times 3 is 6. Those are both factors. Okay? What's the connection between the factors and the roots? Well, I already solved this. Where each factor is equal to 0, that tells you where the roots are, right? Okay, so where, let me word it, where the values, like the book, of x, which make the factors 0, are the same as the roots. Have I written that word a couple times today already?
Same.
Same? I don't think so either. Okay. Where values of x, no, let's skip the word where. I'm talking French. Values of x which make da factor 0 are da same as da roots. Okay? Factors. I'm not going to say memorize that. That's going to be a question on the test, but it's, that's just what we did, wasn't it? Okay? In math, we factored that. We found out using zero product law where this was 0. We found out those, and we found out those are actually the roots. And they're the x-intercepts. Consider this function. Let's go really crazy. Let's call it g of x. Right? Is it still a function? Determine the zeros. How do I do this, Dannon? How do I find the zeros of a function? Okay. This is like totally new, right? You've never seen this before? That couldn't possibly be like x minus 3 and x plus 2, could it? How do I solve that? Hey, have we seen that before? Which brings us to E. State the connection between the x-intercepts, the roots, and the zeros. We shouldn't even have a test. You guys just seem to are so smart. You just notice. Okay? All right. Now we get to the hard part. Fill in the blanks. We have a function with equation. The equation would say y. The function would say f of x. Remember, I keep saying they're kind of like the same thing. Okay? The blanks of the function, is that zeros, x-intercepts, or roots? He's got a really good memory.
The zero function. It's
the zeros, a function has zeros. It's back up here, right? An equation has a root. A function has a 0. Okay? The zeros of the function, if it's graphed, what do we call it? X-intercepts of the graph and the roots of the corresponding equation are the, what goes here? Same. Okay. Here's a graph. It has x-intercepts. What are they? Can we just look on the graph and find them? All right. What's this? There's minus 5. That must be minus 2. And x is 3. I'm having another deja vu. Okay, what's the y-intercept? That's where it crosses the y-axis. There it is. Yeah. What happens at the y-intercept? Always, always, always. The y-intercept, this is worth re-emphasizing. Dan and shush it. At the y-intercept, x is always 0. Okay? I don't care what kind of a funny graph you have. Where it crosses the y-axis, x is 0. Always, always, always. Is that a function, Dan? No, doesn't pass the line test. Okay, it has zeros. Yes?
for the two x-intercepts. Is it always where those two multiply together will equal the y-intercept?
No.
I was just wondering, because it works out.
Yeah, you're right, it does. Okay, what's the roots? You can't write same. There's no blank for same. You have to go minus 2 and 3. All right. Tomorrow, we're going to do that. Okay? So we're skipping that for today. A couple of examples. To find the zeros of a function, same thing. 0 for f of x. This is tomorrow, right? Graphing calculator, we can also use that, okay? Technology. All right. So algebraically, we don't have a picture of this thing. Find the roots. That's an equation. It has an equal sign, but we want it to look like that. Okay, this thing doesn't say equal 0, so how can we make it say equal 0? Yeah. X squared and 8x minus 33 equals 0. Do we think we can factor this thing? What multiplies to negative 33 and adds to 8? You kind of only got one choice, don't you? 3 times 11. Okay. X times, this is still equal to 0. Don't forget that part, okay? I got 11 and 8. I want it to be positive, so put that on the bigger number. And double check it. X squared and 11x minus 8x. What? 3. What happened there? Yeah, that's 8x. All right. Minus 33 equals 0. The roots where this thing satisfies this equation. What value of x will make this thing 0? How about here? Yeah, okay? So those are, actually, I'll just put roots. Okay? How about this guy? He's already done for us. When is this thing going to be 0? When it's 3. Who's pretty good at getting to look at this? What value of x makes that 0? Negative. Okay, and again, if you don't see that, you let this thing be 0. Okay, 4x is minus 5, divide by 4. This thing is 0 when x is minus 5/4. If this is minus 5/4, this is 0. I don't care about anything else. 0 times anything is equal to 0. Okay, it works. Okay, only 2 choices there. And what do we do if we see one like that? If you see what x is, great. If you don't, then you like, is that like a trinomial I can factor? Well, I would want to probably do that. Remove the greatest common factor. Oh, what's that? Don't forget your factoring. That's a difference of squares. Okay? So if x is 2 or negative 2, some of you actually would like to do it like this. And that's perfectly all right. Let's bring 8 to the other side. Let's divide by 2. So x squared is 4. But if you do that, make sure you take both options. Because that isn't just plus 2. Because negative 2 times negative 2 is also 4, right? Okay? And then, oh, good question. If you take the square root of 4, I was going to do 2 steps. Okay? Plus or minus 2, plus or minus 2, same thing. Okay? One more. Find the zeros and the y-intercept. I'm just going to do this one. How do I find the zeros of this? Let it be equal to 0. And factor. What do we want to do here first, Jake? Sorry? Oh, Jake wasn't paying attention. Do I want to go what multiplies to minus 100 and what adds to 15? Or do I want to take out the greatest common factor first to make my life easier? Yeah, you could do either. Well, I don't think you want to put 20 over here. No, I think he was wrong. Okay, he would figure it out, I'm sure. All right? Yeah, I'd much rather go what multiplies to minus 4 and adds to 3, right? Okay, what 2 numbers? 4 and minus 1. X plus 4, x minus 1 equals 0. Hey, if you like it over here, that's exactly the same thing. Doesn't matter. What values of x make this 0? Yeah, negative 4 and 1. Okay, those are the zeros. How do I find the y-intercept? What happens at the y-intercept again? X is 0. Well, that's nice. What does this become? Y-intercept is 5 times 0 squared plus 15 times 0 minus 20. What's that become? Yeah. Okay. Piece of cake. Number 1 to 4. Graphing calculator tomorrow. Well, you don't necessarily have to have one. Let me just quickly, you know how to put this in? You want to see what this thing looks like? Y equals 5x squared plus 15x minus 20. With any luck, it'll show with my window setting the way it is. Does it look like a parabola? Not quite yet. I need to make y a lot bigger. Hey, look at that. Parabola. Okay. Does it look like the zeros are minus 4 and 1? Yeah, and we can calculate that. That's what I'm going to show you tomorrow.